Welcome to part 2 of lesson 8, which is focused on area and being able to determine the area of various geometric shapes. Specifically, today's goal is to determine the area of circles, parallelograms, and trapezoids. Starting with circles, the area of a circle is equal to pi r squared, and that is a formula that you will need to memorize. So an application of that is here we've got a circle and the radius r is 3 centimeters. So how we will determine the area of this circle is that we will plug the radius that is given to us into the formula. So we've got pi times the radius is 3 squared, okay? So when we square something, it means that we're multiplying it times itself. So in this case, 3 times 3, which is 9. And I just tend to like to write pi over to the right of anything else. Okay, so that's commutative property. We've learned commutative property of addition. Spoiler, it also applies to multiplication. You can multiply things in any order. So rather than writing pi 9, I just prefer to write 9 pi. But this is the area of this circle. Now for parallelograms and trapezoids, we actually are not going to memorize any formulas related to them. And so the only 3 area formulas that you need to memorize are rectangle, length times width, triangle, base times height divided by 2, or 1/2 base times height, however you like to say that, and circle, pi r squared. For parallelograms and trapezoids, each one of those shapes can be divided into 2 triangles, and then you will just find the area of each triangle and then add those 2 triangle areas together to get the area of the overall shape. And so right here I've got a drawing of a parallelogram, and you can see we've got the long side lengths are 8, and then the shorter side lengths are 5. And then this dotted line is showing the altitude or height, which is 4. And so with a dotted line, I'm going to show you how I can cut or divide this parallelogram into 2 triangles, okay? And in this case, we've got 2 equal triangles, both of which have a base of 8 and a height of 4. And so we're going to apply the area formula for a triangle, 1/2 base times height. So we've got our base is 8 times our height is 4 divided by 2, and that's going to get us 16. So we know that each one of these triangles has an area of 16, and when we add those 2 areas together, we get 32 for our overall area of the parallelogram. If we look over here, I've got a drawing of a trapezoid, and we're going to use the same strategy where we're going to divide this trapezoid. Yeah, come over here. Divide this trapezoid into 2 triangles. I'm going to use a dotted line to show you how I'm doing that. Now with the trapezoid, you can see we have different side lengths. Okay, so these sides are equal. They are both 5. But this one is 15 and this one is 9. And I'm going to choose both of those as the base for the triangles, just because this height is already given to us. And so that will just make things easier. So we're going to first find the area of this top triangle. I'm going to choose this length, like I just said, to be our base. And then the height is given to us over here with this dotted line of 4. And so for this triangle, we're going to have our base of 9 times our height of 4 divided by 2, which gets us 18 for the area of this top triangle. And then for this triangle on the bottom here, now our base is this longer side length of 15 and our height is still 4. So base of 15 times height of 4 divided by 2 gets us 30. So this bottom triangle's area is 30. We now add those 2 triangle areas together to get the area of the entire trapezoid. So 18 plus 30 is 48, and that's the area of our trapezoid. Last sample problem up here, we have this rather interesting shape. Make sure I'm in frame here. So, like I previously mentioned, you are only going to need to memorize 3 area formulas: rectangles, triangles, and circles. So when you see a shape that is not a rectangle or a triangle or a circle, there is going to be some sort of a way that you can divide up the shape so that it is those shapes that you know the area formulas for, or at least part of that type of shape, as we'll see here. And so I'm going to go ahead and divide this shape up into a right triangle, a rectangle, and a semicircle, which means half of a circle, and we've seen those before. Okay, now that I've done that, similarly to when I was determining the areas of parallelograms and trapezoids, I'm going to determine the area for each one of these 3 pieces and then add them together. So starting over here, I see that the radius of this semicircle is 2. And so if this is 2, this radius, that means that from the center of my semicircle out to any outside point, that length is 2. So that makes this part 2 and also makes this piece 2, which means that the side length of our rectangle here is 4. Okay. So now we have our rectangle. The length is 5. The width is 4. We know our area formula for a rectangle is length times width. So 5 times 4, and we get 20 for the area of our rectangle. Let's move next over to our triangle. We can see we've got a right triangle, and it's got a height of 4. We need to determine the base. I'm going to do that using our line segment principle, right? So we've got this side is 7, okay? And then we know that from here to here is 5 because of this rectangle. And so if this whole thing is 7 and this portion of it is 5, 7 minus 5 is 2. That gets us our base for our triangle. Area formula for the triangle, base times height divided by 2. So we've got 2 for our base times 4 for our height divided by 2 equals 4. And that's the area of our triangle. Last component is this semicircle. So now we need to use our area formula for a circle, which is pi r squared. But then we also see that, again, it is a semicircle, which is half of a circle. So we will divide that by 2. Our radius r is 2. So 2 squared, 2 times 2 is 4. So we're going to have 4 pi divided by 2. 4 divided by 2 is 2. And so this semicircle here, I'll put this on the outside, the area of the semicircle is 2 pi. Once we have the area of all of the 3 different pieces of this shape, we can just lastly add them together. And so we've got 4 plus 20 is 24, and then I'm just going to say plus 2 pi. And that is our area for this shape.